Hi, my name is MImran, and I'm a junior at American Heritage Boca del Rey in Delray Beach, Florida. This year, I focus on investigating the effects of propofol, a commonly used anesthetic drug, on reduced cell proliferation and invasion of human rheumatoid arthritis fibroblasts-like synoviocytes. I wanted to explore an alternative method for treating rheumatoid arthritis because, as of right now, patients with this debilitating autoimmune disease are treated with DMARDs, or disease-modifying anti-rheumatic drugs. Though these drugs do temporarily offer relief to these patients, over time they can cause more harm than benefit because they can decrease the integrity of surrounding tissues and destroy healthy cartilage. By exploring propofol, an unconventional drug, I hope to decrease cell proliferation and invasion of the fibroblast-like synoviocytes, or in other words, decrease cell viability. I hypothesized that propofol would be able to reduce cell viability, but also I wanted to see whether the treatment of RA was drug dosage dependent. Therefore, I tested 3 different concentrations, 30, 60, 90 micromolar concentrations. I suspected that as the concentration of the drug would increase, cell viability would decrease. A little more background on rheumatoid arthritis. In this disease, the body's immune system attacks the synovium, which is the lining of the joints. The synovium creates a joint capsule in which we have synovial fluid that allows for the movement of our joints. The synovium itself is made of synoviocytes, and there are 2 different types, type A and type B synoviocytes. In my experiment, I used type B synoviocytes because they are fibroblast derived and are directly triggered in RA. To perform my experiment, I used a 48 well plate monolayer culture of my synoviocytes. I developed a treatment matrix in order to determine in which wells I would be administering each concentration of propofol, and after delivering the treatment to the cells, I incubated the well plate for 48 hours. After 48 hours had passed, I performed an MTT assay. An MTT assay is an assay that measures cell viability by creating purple crystals in the solution. These purple crystals measure the metabolic activity of cells and can therefore determine how many cells are still living. The more purple crystals there are, the more living cells there are. The well plate was placed in a microplate reader to read absorbance values at 570 nanometers, and my results show that there is a 60.38 to 65.45% cell viability, which translates to a 34.55 to 39.62 decrease in cells. In my future research, I would love to explore different pathways such as the nuclear factor kappa B or NFKB pathway in relation to treatment of RA with propofol. For example, the NFKB pathway is a pathway related to inflammatory responses and controls the gene expression of certain transcription factors such as P50 and P52. Previous research has shown that propofol is able to limit the function of these transcription factors. In other words, by stopping these proteins from functioning, any or most inflammatory responses would be eliminated, therefore offering a cure not only to rheumatoid arthritis but also to other autoimmune diseases. Doing research has been such an amazing opportunity and has allowed me to meet so many new people, professors, and other students who share my love for science. I hope you are able to learn more about what science research is like, and if you're a high school student, I hope that hearing about my project will inspire you to do research in the future, because science research goes far beyond your school science fair and gives you so many amazing opportunities as a young student.